Welcome everyone to this year's extra session of the Digital Classicist Seminar. And first of all, before I introduce today's speaker, I would like to remind everyone that we are recording the session, but only the talk, not the discussion. So feel free to speak openly during the discussion. And I am very honored to introduce today's speaker, Adam Anderson. Adam is a language enthusiast, especially interested in the Semitic languages like Hebrew and Arabic, and then also the ancient ones like Akkadian and Sumerian, which is not a Semitic language, but an ancient Near Eastern language. He did his BA in linguistics at Brigham Young University and then studied Alt-Orientalistic at LMU for several semesters, which is why he speaks German very well, and you are welcome to also ask your questions in German afterwards. He did his PhD in Ancient Near Eastern Studies in 2017 or 18. I have found both numbers online, so I'm not exactly sure.
Yeah, technically, I was already in a postdoc at Berkeley by 16, but it wrapped up in 17, and then the dissertation was published in 18.
So. Okay, so 17, 18 at Harvard University. And the thesis has the title, The Old Assyrian Social Network, an analysis based on the old text from Kültepe Kanesh. He was then a Mellon postdoctoral fellow in the digital humanities at the University of Berkeley and served there on the advisory board for digital humanities and also developed the curriculum for the digital humanities minor that they have there. He was also a postdoctoral lecturer at the D-Lab in Berkeley, which is the data lab of the university. And now he is the co-founder of TokenWorks, offering consulting for all kinds of text processing questions from NLP to graph databases and knowledge bases, and of course linked open data, which will also be a topic of today's talk. With the title Evaluating Cuneiform for the World Wide Web, Fantastic Use Cases and Where to Find Them. And Adam has put several other people of co-authors on his title slide. I will not introduce them, but one of them, Timo Homburg, is here in the room with us today, so he can also be addressed in person during the discussion round. Please, Adam, go ahead.
Thank you very much. That was very kind of you. It's my pleasure, of course, to be here. Thank you. And I'm really glad to see so many people that are already familiar with cuneiform writing or other forms of script. I think that is really foundational to the impetus of this study. I think for those that don't know what Assyriology is and in cuneiform studies, it usually comes as a surprise that Assyriologists don't actually work with cuneiform very often when it comes to the digital world or World Wide Web. And if you are a classicist from Greek or Latin, you can imagine only working in the QWERTY or QWERTY's keyboard, and what a limitation that might be for actually working with your text as primary sources. But that's exactly what has shaped Assyriology in so many ways, the transcription and what's called transliteration. So this study went about looking at how to create a universal conversion of all of the digital databases online and certain projects that have attempted to do that. And of course, each project that goes about a text conversion does it differently. So this is why the title Fantastic Use Cases, or in this case, sign lists and where to find them, is at the heart of this, that each study is its own unique mythical creature and is worthy of investigation, but definitely we should not make the mistake of assuming that all of these projects are using the same methods or the same sign lists, because the encoding methods for cuneiform are slightly different depending on databases and data sets that you choose to begin with. Okay, so that's an overview, perhaps like a short overview, kurz gesagt. outcome if we maybe start from the end and work backwards. I think I can't click on anything until the unfixierte goes away. Can I? Oh, this is just moving around. Okay. Let's go here really quickly to look at some outcomes. So right now we're running a query of Wikidata's signs that Timo and I have worked on entering in from the Altbabylonische Zeichenliste. And you can see here that we have entered in the signs and fonts for many of the periods, different periods that you see. And you can see these here on this side of the screen. So again, it's a fallacy to assume the cuneiform is one thing. It's a multi-headed beast. It's the Hydra. You cut off one period and you get 6 others. You know it's just like Arabic has the dialects and needs to be studied from the dialect level. So does cuneiform in general, but Akkadian specifically that we'll be talking about here. Now these you can see in our efforts to create a comprehensive repertoire of signs and sign lists in Wikidata in open source publication, we have gathered together fonts and have been talking with font creators so that we have a representative font for as many time periods as it's been created. And this, of course, fonts are this kind of extra layer on top of the Unicode encoding of the sign, which also took place in a somewhat haphazard way in the late 90s, early 2000s. And as such, it was almost rejected at the same time it was created by Assyriologists, unfortunately. So this is an attempt to create a renaissance time for bringing back resources that were made and somewhat neglected online, as well as to bring together the different links in linked open data and linking these as well to the secondary sources, reference works, and publications. In this case, linking to the book itself. And as you can see, it takes us right there. And that's one of the benefits of linked open data. These links were added by Timo, thank you. And many of the characteristics that we're looking at on this page, of course, have not yet been digitized. They still only exist in image form. So there's still lots of work to be done when it comes to the font creation and the digital representation. But in terms of what we can say about each sign, we have a great many number of triple statements, linked open data statements about that contextualize each sign in terms of script, in terms of language, in terms of time period and phonetic values, and then the different sign lists in which that sign appears. Now, this, of course, is meant to be something both for machine learning purposes and a pedagogical tool, because sign lists are very often a pressure point for learning cuneiform right from the get-go. Which sign list do you use? Well, it really depends on what time period of text you're reading. Of course, as you saw, these signs change in their appearance over time. And then, of course, all of this is located in open source publication in Wikidata with the different time periods and different lexicons represented with references to the page numbers. So these are really like the outcome of this study. So now that I've explained the overview and the end, I can kind of fill you in on the middle. And this is where we'll get into the fantastic studies that have attempted to take databases and data sets of cuneiform texts and turn them back into the original writing system of cuneiform. Okay, so these are the 5 main sign lists that we looked at for this study at this time. There are additional studies, of course, and that will continue to come out. And I think that it's something that, out of interest of my own and also out of necessity for what we're doing in linked open data, it'll be easy for me with the code that we've created to extend upon this. So all of the methods that I employ for these types of counts and valuations are reproducible Python Jupyter notebooks. So as you can see, again, these sign lists are not all uniform. As you would imagine, there's a certain number of signs, of cuneiform signs. That's a finite number. And yet that number is variable. The signs themselves have a certain amount of variability in each of these studies. And then the number of values for each sign varies widely based on certain formatting techniques and choices, stylistic differences. So these are the basically two dimensions of the sign that are very often conflated and confused in studies that don't understand that cuneiform signs have a label and then they have a series of values that may change over time. But each of these studies in and of themselves are a unique and fantastic beast, something that's worthy of evaluation. And unfortunately, with very many digital projects and products, they do not get evaluated very well. They do not get assessed by other scientists saying, can I reproduce your work? Can I do this and or extend upon it to improve the scientific process? And so I think this is another motivation for this work that we've been doing at UC Berkeley. So the first stems from the CDLI. Now the CDLI is not a sign list. The CDLI is the Cuneiform Digital Library Initiative that goes back, to the, I think late 90s, early 2000s. Bob England was the one who kind of mobilized that. And it contains about 350,000 cuneiform documents and inscriptions. And it's by far one of the largest, if not the largest, online database for cuneiform. But there is no sign list linked with Cuneiform Digital Library Initiative, which is interesting. And also there are no cuneiform signs in the CDLI either. It's all in transliteration. And then, of course, they have the images and the metadata catalog for each document. Our goal in beginning this project was to work with that data set of 350,000 texts and to convert them to cuneiform, Unicode cuneiform signs. Now, of course, your eyes are really wide, Kale, because you know that the archaic signs do not convert. And so there are an extreme amount of challenges with that, which is, as you see the @ symbol, the ampersand, the times, the period, the bar. These are symbols that are used in order to communicate complex logograms and complex signs that have not yet been encoded in Unicode yet. Those, fortunately, have been helpful in understanding for linked open data, which signs are not yet encoded. So that has been something that we've been able to encode in Wikidata as well already, which means we have URIs for those signs, even though we do not have Unicode equivalents yet. So all of this is an attempt to create permanent identifiers for signs which up until recently have not had an identifier even. Of course, the kind of discussion taking place on the side is, in a sense, this comparative analysis across these different studies. So a lot of what the other sign lists contain reflect to some degree the text in the CDLI, but of course not comprehensively, because the CDLI contains so many archaic texts and things like that as well. Basically, the takeaway that we learned in this process is that conversion from transliteration to cuneiform is an error-prone process. It's not foolproof. And even with the rules that have been developed, say, by Steve Tinney for converting, there is still kind of a gap there that needs to be traversed, and which we're addressing, again, programmatically in Python Jupyter notebooks. So this is an attempt to be a one-size-fits-all solution But formatting issues are an aspect of this. And I'll get into that later, but this was kind of our starting point. And it formed a kind of backbone for the sign list repertoire as we know it. Then we go into the New Elena sign list developed in Helsinki by what's his name again? Tommy, that's right, yeah. And he of course took quite a number of the signs from the CDLI, but largely this is coming more from the ORAC data set, their sign list. They've been using this in the work that's been going on with ANE in Helsinki, as they've been analyzing the Neo-Syrian corpus and doing a lot of work with point-wise mutual information and the kinds of semantic studies that you can do when you're analyzing the text at a much more granular level. Overall, the sign list in New Elena fares very well. It's one of the best, most represented sign lists online. It's very safe. It doesn't contain any real problems really that we've noticed. And as you can see, it kind of mirrors what we found in the CDLI and another large sign list. So it is really a useful tool that they've developed. It's open in GitHub. It's an open source tool. And of course, it's something that learners of Cuneiform may or may not know about. And that's the interesting thing about these. These are representative to some degree of the published sign lists, say like Borger's or Mittermeier's sign lists. But it's actually made more for the digital side of the field, seriology, and useful for machine learning purposes. So if you wanted to work on machine translation tasks and things like that, then this sign list would come in handy. They do follow the same conventions that the CDLI data set has, with these special symbols to represent the archaic signs, but they essentially have normalized many of their signs to coordinate better with the ORAC sign list, and I'll get into that one in a minute. Okay, so the third sign list that exists in a similar state and for a similar purpose is called Academia, or it's in the Academia GitHub repo. It was made by Shai Gordon and his team, and probably most likely it seems with the purpose of machine learning again, for machine translation and for some of these types of conversions between transcription, transliteration, and the cuneiform signs. They, since Shai was driving this and is very familiar with the discrepancies in signs from Hittitology and Assyriology, they really took a broad approach to the sign values, and therefore they cover the majority of the sign values more so than any other. They also took a unique step in kind of normalizing or removing certain special characters and symbols, because those rarely match up very well in a conversion process. But I think in general, they have the largest number of sign values online. And I think they did this because they're working primarily, at least their initial target was Neo-Assyrian texts, and they were working on building machine translation tools for Neo-Assyrian. And one of the methodologies for machine translation is that you get texts in alignment, parallel formats. So they chose to test whether or not transliteration or Unicode cuneiform have an advantage when it comes to a machine translation task. And as they found, basically the they scored much better with the transliteration than they did with the Unicode cuneiform. That's largely due to the challenge of tokenization. A tokenizer will randomly assign Unicode cuneiform signs into its matrix because there's no reference point for those signs. Those are brand new, unique signs it's never seen before. And in order to get a contextual embedding, in order to make sure a sign has some kind of meaningful mapping in that matrix, it has to see the sign in a certain n-gram context with a high frequency. Well, of course, you can imagine some of these signs have very low frequency. They appear only once or twice. Therefore, you get a lot of random mappings of Unicode cuneiform signs in that n-dimensional matrix, which is why, even though transliteration is a mess with all the hyphens and all the brackets and things like that, if you don't clean them up, it tends to map a little bit better. But the tokenization process for machine translation in basically any machine learning task is still the biggest hurdle. And cuneiform encoding or transliteration encoding scripts won't change that problem. So it's kind of an interesting evaluation that they ran, and one of the reasons why they wanted to convert the text to cuneiform in the first place. Okay, the fourth project is one that was done by a team of scholars, one of which Dan Lu Chen, I think his last name is, has studied ancient writing systems, including ancient Chinese and logographic and ideographic and logogram languages. And a lot of the purpose of their sign conversion was to see if they can cross-reference the images on a text, so image recognition, with the Unicode cuneiform and start creating mappings between them. They used a pretty large pool of material when it comes to both images and the signs, but they basically chose values that were representative of the text that they selected. So it wasn't meant to be like academia, a comprehensive sign list, but rather one that was customized and curtailed to the images that they selected from the CDLI. We'll get into the problems of that shortly. But basically, because of this, their sign list is very unique. It's still accessible. It was published in the Digital Humanities, Open Humanities Journal, I believe, and they published a data set in Zenodo. The problem is that because they used images that are not in a Creative Commons license, CDLI's images are not owned by the CDLI, but by the museums lending them to the CDLI, that data set is currently inaccessible in terms of the photos that they were working with. So their study is not reproducible, but their sign list is still accessible. And so we evaluated it anyway. And essentially, this is, you can see in 2023 of December, they published it, and shortly thereafter, because of the rights and permissions required, it was taken down and it's no longer accessible. This is, of course, a cautionary tale for any project looking to use images that are not in a Creative Commons license, and especially our project focusing so much in linked open data. We really make sure that every resource that we're pointing to exists in Creative Commons first of all, and that's not always easy with the publications in the seriology especially, but it's necessary if you want to do reproducible work. We'll circle back around to that, but the next study, one that we looked very closely at, was this project by Dirk Rode in Leiden. I know I'm mispronouncing his name because I can't speak Dutch, but it is called TextFabric. Fascinating project that started off working with I think Hebrew texts and other languages, and their approach to to the text conversion, text cleaning, and transmission from one medium or one format to another was very thoughtful, was very comprehensive in terms of machine learning workflow. It wasn't just a match, find and replace, search and replace kind of functionality. It was rather to think about texts in a kind of linked data, triple statement format in the first place. So it fits very nicely with linked open data. But one of the challenges in understanding what they've done is that the process can sometimes be a bit opaque about how you get from the text in the database to the outcome of the cuneiform sign itself. It does take reading a thick manual and really understanding Python to understand what the workflow is. But their work is really innovative and in a lot of ways was very interesting to see some of the choices and thought process that they made when converting text corpuses, smaller corpora in the CDLI. And the two corpora that they chose for text conversion from transliteration to cuneiform was the Old Assyrian and Old Babylonian texts. So their sign list reflects those corpora for the most part. I know that they also worked with UKale on the archaic texts, but I don't believe they did any conversion for those where they were working with SVG files for the images.
No, actually, they went from CDLI transliterations.
They stayed with the two.
But I had to sit next to them for many days and weeks to make it make sense. So
yeah.
It's not a straightforward thing.
No, yeah. It's fascinating, kind of thoughtful process that, was kind of interesting. Some of the choices that I saw and distinctions that they made in which sign converted, which values, readings of the signs converted to which sign. Well, I'll get into that here. Basically, what we did is having done our study with the CDLI data and TextFabric having pulled its data from the CDLI, we were able to compare our two studies to see which of these had a better conversion outcome. And I think that was a really interesting and an important comparison to make. And what we found is that there were certain issues in the sign conversion that was taking place in TextFabric that didn't match up with what we had done and found in the CDLI. And it basically boiled down to about 10 signs. So it's not a serious issue. It's something that was most likely rather, if I remember right, from the conference that we attended in Leiden, had to do with a certain choice they made when converting. So you can see that the sign T2 or D2 was rendered in an archaic sign instead of the standard here, Wa was rendered as Ba in TextFabric, which should be Wa instead of Ba, and Com was expanded rather than contracted into the two signs written together here. And this happened a few other times. I don't know why, but Il was mapped to all. So again, like certain choices of signs maybe got confused in the conversion process. But again, it was only 10 signs, so it wasn't a comprehensive failure, but it was a peculiar outcome that these 10 signs in particular essentially boiled down to perhaps an incorrect choice in which Unicode signs to convert to. So not a major issue, but something that, again, is the reason why evaluation is important for every project. And in fact, contemporary studies that are converting, let's say, the same text in different ways could be contrasted against each other to see which outcomes work the best. And I think that this was a really helpful one for us to realize where our conversion of the CDLI data was standing in our reproducible code. Okay, so the kind of final sign list is that from ORAC. And ORAC is a project-based database. So they don't do what the CDLI does, which is try to create a canonical catalog of all the cuneiform documents. Instead, it's a platform of about 150 projects that are like digital publications of cuneiform corpora. These projects are curated by specialists, and very often they're accompanied with translations that are more proprietary. But the cool thing about ORAC is that all of the data is in CC0, at least the data that is in free use. Translations are not necessarily, but the signs themselves and most of the data in the database are. The ORAC sign list also hosts lexicons like the Sumerian, EPSD, Electronic Pennsylvania Sumerian Dictionary, version 2, and they have for each project a lexicon that lies in the back end. So a lot of this is just really accessible and very noteworthy in terms of a digital publication. And they have gone to the nth degree to curate a sign list. It used to be called the ORAC Global Sign List. It was truly like a monumental task of documenting both the signs and the sign variants in Unicode, and truly remarkable work. It still is ongoing. Steve Tinney and Feldhaus and the others involved in that have invested a lot in the Unicode proposals as well, and that's still ongoing. I think there's Unicode proposal for Proto-Elamite signs as well right now, so I think this is still an ongoing process. And therefore, they include many more unique sign examples and sign variants in their sign list, more than anyone else. And as we reviewed this against the CDLI data, of course, there was a lot of things that were just very different because each of these projects are oriented and framed differently. The data sets in the databases are very different, but we realized that the OSL was creating a kind of standard in terms of digital sign lists. And I think that was one that we ended up really interested in then using as a point of comparison across the other sign lists. So we kind of rode that fantastic beast for a while and compared it against the other sign lists. And by and large, these are, I think, really telling as far as a litmus test of how comprehensive the other sign lists are in representing unique projects, unique corpora. And you can see here that we ran essentially two forms of evaluation against these sign lists, where the sign list was normalized, where these two sign lists were normalized and matched, and when they were matched as is without any normalization. And of course, you remember, like, what I'm talking about normalization has to do with diacritic marks. So whether there's a subscript 2 or a regular number 2 or an accented number 2 on one of the sign readings for those familiar with cuneiform, you know what I mean? If you don't, talk to me afterwards. I'll explain the complexities of the syllabic readings and values of the sign. But essentially all of these like nuances that are more or less like scribal tools for explaining the difference between syllabic homonyms, synonyms, essentially, that Egyptology could learn something about. I think they have the complexity of vowels and not having articulated numbers for their vowels, whereas the Syriologists have articulated those same, synonyms with numbers. In any case, you can see that academia and New Helena both match up quite well. New Helena has the largest match in general, whereas academia has a number of signs in addition to the OSL that most likely reflect the CDLI. And as you can see, the CDLI matches up the least with the ORAC sign list, and that's because, like I said, they're oriented very differently. The texts are formatted differently. Even under normalization, the matching process is not a simple one. So I think this is kind of, again, like maybe a cautionary tale for those who think that they can take transliterations from the CDLI and go over to ORAC's Cuneiform and turn that into transcription or Unicode cuneiform signs. These databases do not just intuitively speak to each other. The formats are different and the signs and values are quite different. And of course, the type, text, and time periods of the texts are also different in both databases. And I think that this is something that maybe isn't intuitive to a seriologist, but that is a noteworthy discovery that we made in this process for as we're comparing these different sign lists together. So overall, the cross-cutting insights here is that the sign values converge while the labels may diverge. New Elena and Academia align more closely with ORAC's data, but the transliteration conventions diverge still widely, especially in comparison with the CDLI. And I think that for these niche studies like CUNY-ML and Text-Fabric, those should be seen for the corpora that they're working with, but be cautious in using those sign lists as such, because I don't think they're meant to be a universal conversion tool for anyone out there working with cuneiform text and wanting to convert to Unicode cuneiform. Academia, of course, is a high-value hub, and in fact, it contains more values than New Elena. But Academia would not be what it is without New Elena. New Elena did the trailblazing work of retrieving the values from the OSL and putting them first into the GitHub. So it's pretty clear that Tommy's work was really foundational in the process. And of course, as you're converting, there's going to be missing values because many of these signs are still waiting for Unicode encoding. And this is something that Timo spoke about in the digital Ancient Near Eastern conference, that we have somewhere around 900 signs that we can point to that are missing a Unicode encoding, that are not even archaic. They're ones that are just, that got looked over. And I think that there are some discussions that could take place in terms of where fonts may represent certain benefits for aspects of these signs, especially with the GUNU, TENU differences that take place, the variations that take place in signs. But we can maybe leave that for another time. In general, each of these fantastic sign lists are unique studies in and of themselves. And I think there are some that are more representative than others. And I think that it is, again, like a motivating factor for why we need Wikidata in the mix, why we need a linked open data solution for each of these fantastic studies to be linked together in a meaningful way so that we can see which signs are represented by digital scholarship and digital projects happening online, which of these are receiving evaluation so that new and subsequent research doesn't just, pick up the sign list without knowing what it is that's entailed in that sign list. For example, taking the CUNY-ML sign list, I've seen this and I've reviewed papers for the ACL, the Association for Computational Linguistics, for workshops. And I think, if you don't know where the sign list is coming from and you just use it as such, there are pitfalls involved and there are dangers with that. So each of these, I think, should be seen for what they are, but perhaps maybe even better linked together and pointed to in Wikidata. And again, so finally drive this point home that while we're not at the level of academia and values of Wikidata, this number is growing. We are building this, and we're trying to build a community around this. So if you do have interest in contributing to linked open data, getting your name published in Wikidata, reach out. Let's collaborate. This is definitely a linked open data publication, and it's one that I think will benefit not just future machine learning studies in digital cuneiform, but also pedagogical and curriculum development, where what you're trying to do is teach a class about a subset of texts, and the sign lists and the fonts are readily open for development. And I believe that's where this ends. So I hope that I didn't go too much over. But if there are any questions, I'm more than happy to receive them. Thank you.